that. If it messes up again, I will just not care. Okay, yeah. Okay, so I'll get back to this. Now pass on to materials, because one thing is that we have these different objects and different groups. They will also usually have different textures and also different material properties. And for OBJ, unfortunately, they don't really support materials, so we have this companion file, which is written in something called a .mtl file. So typically you mention what file name you have by saying mtl-lib, and then the file name of the file comes. This you usually do in the beginning. I'll show an example. And then basically you have a reference to a material. So when you say use material, basically means that you're going to use this texture that follows here. So I can give an example. Oops. So you see here, that was not a very good one. Let's go to the sponsor again. Be a bit more consequent in that one. So if you see on top here, you see mtl-lib sponsor.mtl. So that's the material file you use. If you go in here, you'll find that one, and you can open it. And here you see a lot of new MTL, which refers to basically new MTL means new material. And then what follows it is a reference to a texture, right? So every time you refer to this in the file, it means that you use this material with this whatever it is. I'm going to get back to that, and then that texture, for example. Okay, so basically, yeah. And then there is very similar to the .obj file. You have these letters that every line starts with. So, for example, if it starts with Ka, it means. Any idea?
Ambient light?
Yeah. So the ambient light of that group or that object, for example, will be specified by this RGB component that follows. And then you just put in the RGB value you want on the ambient light. And you have the same for diffuse light, specular light, and you have the exponent of the specular, and those sort of things we talked about on the lighting. And then whether or not you have transmission through the object or not, whether it's transparent or not, if this is set to 0, it's opaque, for example. And then you have these predefined illumination models, which I have listed here. I won't go into all of the details, but basically, for example, if you set illumination model 0, it means that you have color on and ambient off. So if you have set an ambient and you set this one, then of course the ambient light will not be there. And then 2 is highlight on, which has to do about the spectral reflections and those sort of things. So similar thing. And this material can refer to just material textures, which are used to. Also bitmaps, if you remember what that was some weeks ago. It can also refer to bump mappings, which I haven't talked about yet, but I'll get back to later. It's basically a way of making textures appear by manipulating normal vectors on your surface. So the light basically makes your object seem like it's ragged or structured in some particular way. Okay, so let's just go to an example instead, because I think it's easier to deal with. So we go back to this cube. Oh, sorry, by the way, if you want some, there's also a very detailed specification of this MTL format, just as you have in the OBJ. So if you want to read yourself up on this, you can click that link, and you will have the same sort of thing here for the MTL format. So here I think you will probably get to know everything you need to know about this. Okay? Right, let's see. Okay, so I said this thing, yeah. Let's go to the example. So here's just the example of this cube. The material I use is connected to this, yeah, sorry, I have to be a bit more systematic here. So let's go to the cube itself. So here you have this default.mtl, that's the name of the material file connected to that. And in here you see reference to a texture, default.png, which is the texture that follows along with this zip file that you downloaded, right? Which is just a simple checkerboard. And if you go to the cube.obj, which I showed some slides back, let me go back there. You see that the first thing you define in this one is mtlib default.mtl refers to that particular MTL file, right? So you do that in the OBJ, you go to the MTL and you look inside that one. there. So a lot of back and forth. Okay, so again you have a hashtag for comments, and then basically here you set the exponent of the spectral reflection. You have the index of refraction. You see PR0 means that you have an opaque object, means that it's not transparent. You use illumination model number 2, which is basically highlighting on, and then this is, what does that mean? Ka111.
Ambient lighting.
Yep. So it's set to white basically, and then the diffuse light is set to white, and then you have a very small speculative bond. And then you basically get that appearance if you use that on that particular texture. So it's very neat because you can put up your geometry, but you can sort of put on the textures which will decide how it interacts with light later on, basically. So that's maybe one of the advantages of it. Right. So if I go back to this Sponsa example here, I can look at material ID. So we have about 20 materials, so 20 textures that you deal with in this one, as you can see here. Well, actually you have three material definitions, but you have actually fewer textures. It's just that you set different lighting models on those. For example, see, you have 2 different arcs here, and they have slightly different definition of how they react to light. So I think you can see if you go back here and try to light the model. So just look at 2 examples. Fine. So we can go back to this Sponsa and, for example, find that. Let's start on top. G. Find. So we can go back to the arcs on the floor. Yeah.
So you have several texture files, but you have all the texture coordinates are in the OBJ file.
Yeah.
Where does it say which texture file to use?
Yeah, but, I'm coming to that. So you see here, for example, on these arcs on the floor, these ones, you have, let me see, that was the MTL, sorry. So you see, you say use material SP00 loop Mali. It's a bit cryptical. You could probably use more clear words, but let's go to the MTL file and see what material that is. So I have the MTL file here, and then you see here is a new material SP00 loop Mali. And here comes basically the definition of the specular component, the ambient. Here you basically only have diffuse light, and then you see the texture here. Right. So it's spluke.jpg, and if you go back to the here you can find that one. So spluke. There it is. So that's the texture you use for that one, right? Or was that?
Yeah.
And then, for example, if I would look at let's look at for example one of the pillars. You will, for example, in this particular case, you will see that these 2 actually use the same textures, but they're a little bit differently. So if you go down to these arcs, you will see something very similar. They just reuse the same texture. But these pillars here have different textures again. So let's go down to them and just to show another example. So yeah. So here comes the group that's connected to. Oops, no. Ah, yeah. Okay, they first defined it like that. Okay, I see. So which one is this? Well, they use material SPO0 stub cut. It's not the best sort of naming anyway. So let's see if you find that one here. Yeah, here it is. So it refers to this material. And here you see you have another sort of illumination. It's also only diffuse components here as well. It uses illumination model number 2. It is not transparent, blah, blah, blah. And it refers to this texture, 0.5 stub.jpg. Let's see if you find that one here. There it is. And then we see that, of course, this refers to these pillars here. Right? The texture. So it's composed part by part by part, basically. Did I answer your question?
Yes.
You did? Okay. So basically, each of these groups have one companion material, and all of them are defined in this one file, and you basically have them all laid out like that. Probably also a bit interesting to look at this nanosuit in this same respect, because if you look at that MTL file, yeah, you will see here you have, it's a bit more explicit to see. So ARM, for example, you have those lighting conditions, and you refer to this particular texture, and body, glass, so on and so forth. And here you actually only have 6, I think. Right, so that's how you build this piece by piece. Okay, let's go further.
Sorry.
Yeah.
Can you show me the OBJ file after the class?
Sure, yeah, of course. We can do that. Right, now one very important thing. The object loader I showed you earlier today does not work for these materials, right? So then you have to extend it, and it's a bit more complicated. So the lab on Tuesday will have textures, but they will be sort of patched on afterwards. So you don't read them from MTL files like you do here. But you have these loaders for C++, which is quite nice to use, which is available through GitHub. You have a tiny object loader, which you may use on Lab 7 if you don't want to write your own. It's basically a compact fast on this C++ base, basically, and it has a nice integration with OpenGL. So it's, yeah, I think that's all the options you have on that next slide is to use this one. You also have a much more advanced one called ASIP, which reads different formats also, the ones I will talk about later. And it's also connected to a wide range of languages. So both of these are available at your disposal if you want to. The tiny object loader, just to mention a little bit, you basically enable it using this hash-defined tiny object loader implementation. You have this H file you include. And basically, it's quite similar to what you have in C++. It's only that it has some sort of different name convention. For example, a float, you use this tiny OBJ double column, and the real T basically refer to floats for some reason. I don't know exactly why, but that's what they do. And then you have attribute arrays in a very similar way, which is called attribute underscore T. You have vertex indices, which is basically shape underscore T, and so on and so forth. You can basically look at this specification here, for example, Tuesday or before Tuesday, if you want to know more about it. I won't go into details of the example here, but on this page you will find information about this. So if you go to that one, you will see some description of it, some versions, data structures, what they refer to, and you'll find an example of an object loader using this. So you can do more advanced things with this one, and in addition to what you had in this this example I showed you, this simple object loader I show you, this also has a possibility for materials as an option. So that's what I intended to say about OBJ files. Do you have any questions about that before I move on? Just talk about some of these others, which we will mainly use OBJ, or that's what we will be using in this course, but there are other ones that's interesting for curiosity. First one is this 3DS, which is proprietary, so we will not really deal with it a lot. It has a binary format. It's one that is used quite a lot commercially. Yeah. It has drawbacks that it only allows up to 65,000 triangles. So, for example, this sponsor we have, it cannot really render that in a very nice way. So it has a sort of low poly appearance on many things. It doesn't have any option for arrangement of data, so it's not as flexible as OBJ. But of course, the advantage is that you have the possibility to, the file structure looks the same way always. So it's no option for making these nodes and phases appear in different orders and so on and so forth. yeah, I won't spend much time on this. It's a binary format, so it's hard to read, but if you look at the example how it's built up, you see more or less the same things as you saw in the older jail. So you see that you have, triangle meshes, vertex lists. You have, of course, the support for lighting here, you see, so light, like a spotlight type. And then you have lots of materials, which is also included in this file, and so on and so forth. But we won't deal so much with that, so I'll just skip on to the X3D, which is basically a web standard, which is XML based. You're familiar with XML?
Yeah.
I'm not, so anyway, yeah. So that's nice if you know that, and you know basically how the file structure looks. Yeah, it also has the possibility for interaction, which makes it a bit interesting. So you can interact with this one, and it has advanced compression modes, which is nice when you're dealing with a lot of textures. So I can just, yeah, file structure is typically like this. You have a file header. You have the start of the X3D root node, you have a header section which is optional, which basically just contains metadata, and you have the so-called X3D scene graph with child nodes. I will not go into details of this today because I will talk about scene graphs in the next lecture, but I guess you get the flavor from root nodes, graphs, child nodes. It's probably something you heard in some other course. This is basically algorithmic that is trees and graphs. And the root node. So I'll just very briefly show an example. So you see that you probably recognize this if you know XML or other markup languages. So it's a very similar structure. You have a starter file, you have some header section. Here it's empty because it's basically no metadata here. It's basically this red sphere show up here. So it's very simple explicit code. So you basically use scene and end scene, and in there you have some shape. And basically the shape has the sphere radius 2.0. The appearance is basically referring to material. You just have a red sphere with diffuse colors, and you set diffuse equal to 1.0 and 0 GB coordinates and so on and so forth. Yeah, so it's pretty straightforward built up. I think you also have another example, which is a bit more advanced, like this thing here. The spinning wheel. If you go down to the file, you'll basically see that it has two chunks. One here that basically defines this Earth image, and then you have another thing for the text. And you'll see a lot of known things here as you have in OpenGL, that you have rotation, operation, blah blah blah. So it's rotating around the y-axis, for example. The special thing is that the texture information may be loaded from other web pages. So we may have other models that we find on other web pages that you import into this, and you can play around with it and make some quite neat things. So for example, on this page, which I linked to, you can see some examples of this format. Let me see if I can get this up without crashing my computer. It takes some time to load. Let's see, interaction camera. So you can basically move around in this model using your mouse, right? Oops. You can look up in the roof and those sort of things. So they have a sort of a, it's very, you can do many interesting things with it, basically. And it comes in different profiles. I don't really have time to go into details, but you have everything from a base profile, which is basically, everything from the simplest interchange model here, which is basically just a basic profile, geometry, textures, lighting, those sort of things we saw in OBJ. But it also has this up to this very advanced sort of full 3D interaction, where you can include animating characters and all sort of things. So if you'd like to know more about it, you have the information here. And this goes back to what some of you mentioned earlier about converting between these different formats. And here you may see why it's difficult, because you receive different 3D formats, or some collection of them, what they support and what they do not support. So what's marked in red is what they don't support. So you see, for example, the OBJ file, which we talked about most, it supports approximate mesh, actually all of them do, and it has a precise one. This 3DS, which is limited to only 65,000 triangles, of course doesn't have a precise mesh, so that lacks. And you see the OBJ has color, material, texture support, and so on and so forth, but it doesn't have any animation support. And you can see that this X3D file basically has support for all, so it makes it a really powerful file format, and therefore many people think it's quite promising.
What is CSG?
Probably I don't know. Oh yeah, CSG. What is that? To be honest, I don't know. Anybody who can idea what it is?
I'm trying to Google a constructive solid geometry.
Oh, okay, yeah.
It's used in solid modeling, it says. By using Boolean operators to combine simpler objects to make a more complex object.
Okay. I see. Great, thanks. Yeah, so I think that's what I like to say about it. So the point is to show that the OBJ is quite limited in the sense, but it does for our purposes, and you have a lot of interesting models there which you can deal with. And you have the X3D, which basically has support for all. I don't think we'll deal much with X3D here. I think it's up to you if you want to do it, but I think we'll mostly be stuck with OBJ, but it's a very interesting format. Also, towards the end, I would just like to mention this this WebGL thing. I don't know if you heard about this. It's like OpenGL for web. It's not
Just heard of it, but never seen it in action.
No, I can, you will find, that's why I showed you, because you can find some, if you're interested in this, you can find some links on it here, which I'll show. And what's interesting is that you can basically have this animation going without loading plugins, for example.
But WebGL uses your graphics driver to render it?
Yeah, I would presume.
No. Because I know that OpenGL makes like calls to the
Yeah, I would guess it does.
to the graphics driver.
I think it has to, otherwise you wouldn't be able to do the things.
So it uses mostly the same functions.
It's mostly the same, but it's built on something called OpenGL ES, which is for embedded systems, so it's slightly limited, I think. But I mean, you can do a lot of interesting things with it. I'm not sure if it runs, but I'm quite sure it has to, otherwise you wouldn't maybe be able to do these things. I can show you some examples. So first and foremost, you can click the first link I showed you just to see if your browser supports it. And if you get this clear here, it basically means that you could run this WebGL things. Maybe. Well, I think this was a good question, actually, because I shouldn't confirm that it does, actually. So it's likely. Anyway, here you have some examples. So, for example, you have these caves here, where you could use, I think, yeah, use WSD to shift. Okay, so you could basically shift around using these play button keys, and then you use left mouse button to carve, do things like that. I think that this here is probably more interesting. Yeah, so here you have this fishes flowing. You can change the number of fish, options, change view. You see it from outside, advanced, reflection. We have some advanced features here. You can basically, yeah, change the field of view. Fog. You could have red fog. Yeah, you can do a lot of things with these things, which is quite interesting. So if this is something you would like to look at, just have a go at it. You find all the links here. You also have this thing called Shader Toy, in which you can just click on these different 3D animations here and basically get up a window with the code on the right there. So it's also pretty interesting stuff. So I think that's actually what I intended to say today. Next week I'll get, yeah. Well, you just stretch it. Okay. So next week I can take up this thing about how you compose these more complex objects from these things you saw in the file, and also talk about scene graphs, which I think is very much related to that. So I can sort that out. Did you see if it was where this was running? This, did you get any information on that?
I'm looking at it. You still have to write shaders in GLSL.
Yeah. I think it should be the same. So probably, I'm not sure. It's likely that it uses your graphics processor basically. Otherwise, I think it would be very hard to be able to display that.
It says you have to update your graphics driver.
Okay, so probably because we all have your yeah. If I hadn't, so yeah, it's very likely. So I guess everybody here will make this thing run because they have upgraded into this course. So.